if you have not yet joined the Pear Deck, please go to joinpd.com, type in the class code VXQIJK, and you'll be in the class and you'll be able to get credit. Otherwise, tell me you're having issues and things aren't working. We'll work something out, no worries. All right, so here we are. We are in 8.1, confidence intervals, the basics. Right, examples and practice problems. Hooray. So first, we're just going to look at an example. All right, about hot dog fat content. Very exciting. So how much does the fat content of brand X hot dogs vary? Right, to find out, researchers measured the fat content in grams of a random sample of 10 brand X hot dogs. A 95% confidence interval for the population's standard deviation sigma is 2.84 to 7.55 grams. Question number 1 is to interpret the confidence interval. Question number 2 is to interpret the confidence level. And question number 3 is to answer true or false. Is this statement true or false? The interval from 2.84 to 7.55 grams has a 95% chance of containing the actual population standard deviation sigma. We'll justify your answer. All right, this is not a question for you guys to type answers to. This is an example that I'm going to show you the solutions to so we can get an idea of what we're doing. So, there it is. The answer to question number 1. Right, interpreting the confidence interval, the researchers are 95% confident that the interval from 2.84 to 7.55 grams captures the actual value of the standard deviation of the fat content of brand X hot dogs. Right, so this is the interpreting what the confidence interval tells us. It says that the researchers, people doing this research, they're really confident, 95% confident that in the range of 2.84 to 7.55 grams, somewhere in there is the actual standard deviation. All right. So this range captures it. It's within there. Kind of think of the range as a fence. It's in there somewhere. We're not entirely sure where, but it's in there. All right. If we were to say that the researchers are 95% confident the interval from 2.84 to 7.55 grams is the actual standard deviation, we would be wrong. That is an incorrect statement. We don't know what the standard deviation is. Is the same as saying equal. Right? We can't say that. We don't have the numbers or the stuff available in this context to say that statement. All we can say is that it's somewhere in there, so we use the verbiage captures or contains or something to that effect. Okay. Question number 2, I want to interpret the confidence level. Right? If many samples of 10 hot dogs are taken from brand X, about 95% of them will result in an interval that captures the actual standard deviation of the fat content. So again, we're using that verbiage captures, right? And if we're saying, okay, if I redo this sampling again and again and again of 10 hot dogs, right, each of those would give me a confidence interval. Of all of those confidence intervals that I've now compiled, 95% of those will contain the actual standard deviation. Some of them might be way over estimates or way under estimates, and they will not contain it, which is why we're only 95% sure, not 100. All right. And then lastly, for the third question, this is a false statement. This particular interval either does, probability 1, 100%, or does not, probability 0, contain the actual standard deviation. Each interval that I get from a sample either 100% does or no percent doesn't contain my actual standard deviation. So we can't make a statement saying there's a 95% chance because that's false. It does or it doesn't. 95% of my intervals will contain it, but each particular one, I can't make a specific statement about each particular interval. What can I clarify about these 3 statements? Because at this point in the course, what we're really focusing on, or in this section particularly, is how we say something. The words that you use and and how you make your statement is almost more important than, it's more important than what you understand it to mean, so to say. Like, we get it. Like, I get 95%. Okay, there's an interval, 95% confidence, cool. If I don't verbiage, if I don't say this in the right way, you're not going to get credit for it on like the AP exam. They're going to say you said the wrong thing. What you say becomes very important. All right? Is there anything I can clarify? So we're going to do our first problem. So our question number 1, going to the prom. For this context, you need to determine the point estimator, right, which a point estimator is the sample statistic. Sample mean, sample proportions, sample standard deviation. One of those items can be the point estimator. You would use and calculate the value of the point estimate. So decide what point estimator you're using, and then what is its value based on this context. Right? Tanya wants to estimate what proportion of seniors in her school plan to attend the prom. She interviews an SRS of 50 of the 750 seniors in her school and finds that 36 plan to go to the prom. Right, so what is the point estimator? What will be the sample statistic we can use in this context? And what is its value? All right, guys, we're going to talk about this one now. All right, so before we talk about the solution here and what is the point estimator and what's the value of the point estimate, look at the problem itself again. Tanya wants to estimate what proportion. Right, that's our giveaway. The point estimator needs to be the sample proportion, because that's what we're dealing with, proportions. Right? And in this sample, what proportion of those that she interviewed said that they're going to prom? Right? We have 36 out of 50. So the point estimator is the sample proportion, which we can notate with p hat. Right? And the value is 36 out of 50, or 0.72. Right? And so that's what we get here as the solution. Right? The point estimator is the sample proportion, or p hat, and the value of that is 36 out of 50. Right, so I saw a lot of you guys saying, Rambo, shh. Sorry, my dog's being a silly guy. A lot of you guys saw that proportion from the sample was 36 out of 50, or 72%. We need to make sure that we're answering the question in the proper context. It's naming these things special things, point estimator, point estimate, so we need to use that term. Right? The point estimator is sample proportion. The point estimate is the value of the sample proportion, which is 0.72. Right. Is there anything I can clarify on this example? All right, move on to the next one. So on this question, we have several parts to consider. Right, we're talking about prayer in school. A New York Times CBS News poll asked a random sample of U.S. adults the question, do you favor an amendment to the Constitution that would permit organized prayer in public schools? Based on this poll, the 95% confidence interval for the population proportion who favor such an amendment is from 0.63 to 0.69. Right, so that's the interval. Right. Our first question A is to interpret the confidence interval. All right, so that's similar to some of the responses we had in the first example problem and in the previous problem. All right. B, what is the point estimate? that was used to create the interval, and what is the margin of error? Right. What's the value of the point estimate, and what is it? Is it x bar? Is it p hat? What's its value? Right. Based on this poll, a reporter claims that more than 2/3 of U.S. adults favor such an amendment. Use the confidence interval to evaluate this claim. Based on the confidence interval, can this claim be made? All right, guys, we're going to talk about this question. I know that most of you haven't been able to finish answering all 3 parts, and that's okay. Most of you were able to get an answer or some thing in for A. Some of you were on B. A few of you started on C. That's totally fine. I know that 5 minutes is pushing it to try to get all 3 parts of these done. So we're going to talk about this. So for part A, right, interpreting the confidence interval. Right, so the pollers or whatever from New York Times and CBS are 95% confident that the interval from 0.63 to 0.69 contains the actual proportion of the population who favor such an amendment, right? That's what that's meaning, right? That interval, the confidence interval. We're fairly certain to a 95% confidence that the actual proportion is somewhere between 0.63 and 0.69. Right. The point estimate would be p hat, because we're talking about proportion, so the sample proportion. And I'll switch to showing you guys the solution so you can see how we can find that. Right, so here's our solutions. Right, so they are 95% confident that the interval from 0.63 to 0.69 captures the actual proportion of U.S. adults who would favor an amendment that would permit organized prayer in public schools. Being very specific. B, the point estimate that would be used would be the sample proportion. Right, this is the context of the question is about proportions of the population. Right, it would be p hat equals 0.63 plus 0.69 divided by 2. Okay, Noemi, have a good day. Thank you for coming. So p hat is found by basically finding the midpoint between the 2 endpoints, right? Or the average of the 2 sides, right? 0.63 plus 0.69 divided by 2, we get 0.66. So that would be the sample proportion. The margin of error, right, we can find that by subtracting the lower bound from the midpoint, right, or the p hat, we get 0.03. So the margin of error is plus or minus 0.03. All right. Because the value 2/3 is approximately 0.667 and values less than 2/3 are in the interval of plausible values, right, essentially half of our interval is equal to or below what they're saying should be greater than. There is not convincing evidence that more than 2/3 of U.S. adults favor such an amendment. So because we have a good chunk of plausible values that are less than the claim that they're making, we don't have convincing evidence that their claim is correct. It could be, right? Some of our plausible values are greater than 2/3, but some of them are also less than, so we don't have evidence to say the claim is true. Okay, we don't have convincing evidence. Is there anything I can clarify?
Can you clarify on B, please? Because I don't know.
On B, yeah.
I think I got it wrong for sure for the because the little thing is the one. I don't know how you got all the thing.
Okay, so here, let's do a picture. Give me a second. All right, so let's consider like a number line, right? So wait, so if you guys want to see what I'm referring to, please go to the shared screen. So I'm sharing my screen on OneNote right now. So you might have to navigate off of Pear Deck for a moment. So you can see the shared screen in Teams. So suppose our distribution, I know this is kind of angled, I apologize. P hat is in the middle, right? And if we go 3 standard deviations to the left and right, it's essentially going to make our normal distribution for the sampling distribution of P hat. The 95% confidence interval, right, is within 2 standard deviations where, I didn't draw this very well, but we get the idea, right? This shaded area represents 95% of the area under the curve. Right? We also know that because my 95% confidence interval goes from 0.63 to 0.69, right, that interval has to be within 2 standard deviations to the right and to the left of P hat. So P hat has to be right smack in the middle of those 2 values. So we can find this value by adding 0.63 and 0.69 and dividing by 2. We're finding the midpoint between those 2 values. And that gets us 0.66. So our P hat, our point estimate, right, is going to be 0.66. Does that help?
Okay. Thank you.
And then the margin of error, the margin of error is what we've added on this side, right? We did plus 0.03 minus 0.03, and that's how we get that plus minus 0.03.
I see. All right then. Thank you.
You're welcome. All right. Anything else I can clarify? All right. So we're going to hit the next question. All right. This one's about shoes. So the AP Statistics class that was in a previous example that we don't have on here, they took a SRS of 20 boys at their school and asked them about how many pairs of shoes they have, and they also did the same for girls in the previous question. All right, so they end up with a 95% confidence interval for the difference in the population means, girls minus boys. All right, and this is 10.9 to 26.5. We need to interpret the confidence interval and the confidence level. So there's 2 statements for this question. First is interpreting the confidence interval, which we've done a couple times already in the previous problems. And then confidence level, which you might want to look back in your notes to see what's the verbiage for interpreting confidence level, because that's slightly different. And so we'll give you all a few minutes to get some answers in for this, and then we will talk about it. All right. So a lot of you guys look like you have a good idea of, or a better idea of how to write the confidence interval, obviously, because that's something we've talked about on the last few problems. Confidence level is probably a little more foreign, and that's okay. We're going to look at the solutions to what these should be, or one possible way of writing these right now. All right, so we get, for the interval, right, They are 95% confident that the interval from 10.9 to 26.5 captures the actual difference, girls minus boys, in the mean number of pairs of shoes owned by girls and boys. And so if you had something along those lines, they're 95% confident that the interval captures the actual difference in the means. You're good. For the confidence level, if we took many samples of size 20 boys and 20 girls from the school, about 95% of the resulting confidence intervals from those samples would capture the actual difference in the mean number of pairs of shoes owned by girls and boys. So again, some of the key things that go on when interpreting the confidence level is saying, if we did this many times, if we took many samples, something to that effect. If we repeated this sampling many times, right? About 95% of the resulting confidence intervals, right, that's plural, more than one interval, because each sample gives us an interval, right? And when we can see all those intervals, 95% of them would capture the actual difference in the mean number of pairs of shoes, right? So there might be some intervals that we get from a sample that might way overestimate or underestimate, and it might miss the actual mean. But 95% of those samples will give us intervals that capture the mean. That's the confidence level. That's what that means. Is there anything I can clarify? All right. We're going to look at the next question. All right. This is referring to the same question or the same kind of context from the previous question. Right? Does the confidence interval, right, the 10.9 to 26.5, I should have had on the screen. I totally messed that up. Right. Does that confidence interval give convincing evidence of a difference in the population mean number of pairs of shoes for boys and girls at the school? Justify your answer. Right. So in other words, based on that confidence interval, right, the 10.9 to 26.5, do we have convincing evidence, or do we believe that there is a difference in the mean number of pairs of shoes for boys and girls? And that's the question we're answering here. Okay. Let's talk about this one. So a lot of you guys are saying yes, that we do have convincing evidence of a difference in the population mean number of pairs of shoes. All right. But a lot of you are missing the reasoning. All right. So before I show the answer, I want to talk about the context here. Right. Our confidence interval, that 10.9 to 26.5, right? That says that we are 95% sure that somewhere between 10.9 and 26.5 is the actual difference between the mean number of pairs of shoes that boys have and the mean number of pairs of shoes that girls have. And this difference is by subtracting girls from boys. So the fact that this is a positive number means that we're essentially claiming that girls have more shoes than boys on average. All right. Does this interval give us convincing evidence of that claim? All right. The answer is yes, and it's because that interval says that we're really confident that there is a difference. That's all that we need. That number needs to be positive. We're pretty certain that that number is positive, showing there is a difference. So because 0 is not a plausible answer, it's not part of our interval, we have very good convincing evidence. All right? And so that's what the solution is here. So yes, since the value of 0 is not a plausible value in the interval, there is convincing evidence that there is a difference in the population mean number of pairs of shoes for boys and girls at the school. All right? And that's supported by that confidence interval. You guys need any clarification or any for more explanation on why this is the answer. Yeah, absolutely. So if we're looking at our confidence interval, right here, let me go back to my OneNote here. Right, so in this problem, right, I have the interval, right, of 10.9 to 26.5. Right, and this is our confidence interval. And this is a 95%. So we're 95% sure that between these two values, somewhere in there, is the actual difference between the population means. So the claim is that there is an actual difference. That if we subtract the mean number of pairs of shoes for girls from the mean number of pairs of shoes from boys, we get a positive number, right? So that's what the claim is, right? I cannot write today. Claim the mean girls minus the mean for boys, right? This value is greater than 0. That's essentially the claim, meaning that there's a positive difference. Because 0 is not in our interval, this gives us great evidence saying that there is a difference. Right? If the interval, right? So we think of this as like a number line here. Let's say 0 is over here. Let's say we're going by 5, 10, 15, 20. Right? This interval is going to be somewhere from here to here. Right? So this section of my line is the plausible values for the difference in means. Right? 0 is not in my interval, which means it's not a plausible outcome. Right? Because it's not plausible, we have good evidence saying that it's not 0. So there is a difference. I don't know if I like way over explained that or if that made sense. I don't know. Hopefully that helped. Okay, you're welcome. Yay, okay, cool. All right. I always get worried that I just become like circular in what I'm saying and then it just gets confusing. So I'm glad that helped. All right. Excellent. The next question is a multiple choice. So let's see what's next. So in a poll, some people refused to answer questions. People without telephones could not be in the sample. And some people never answered the phone in several calls. All right. So we have non-response, undercoverage, and non-response. Right? It's all forms of bias. Which of these possible sources of bias is included in the plus or minus 2% margin of error announced in the poll? Right, and you can choose from 1 only, 2 only, 3 only, all 3 of those, or none of these. There's only one correct answer. Okay, so before I show you guys the answer, remember that the plus or minus margin of error And this is from our notes yesterday, so if you took notes, and I know this was like one line of notes, so it's really easy that you may have missed it. That plus or minus margin of error can only account for error due to chance. It cannot account for errors due to non-response, under coverage, question bias, lots of other forms of bias that have to do with how we collect our sample. So if you'd like to change your response, please do so. All right. And here's our response. None of these, all three of those are forms of bias that are not due to chance. They're forms of response bias and not sampling bias, right? The plus or minus 2% margin of error can only account for bias that occurs by chance, just happened to occur, right? And it's accounted for in that margin of error, saying, hey, we could be a little bit off in this thing that we found. Okay. Which is also why you have to be really careful about like polls and surveys that you see on like news channels, because they're typically polling from people who they know what kind of response they're going to get. And then they say they have this margin of error, but it's a completely biased sample anyway. So, there's that. All right, we have one more question. Is there anything I can clarify on this one before we go to the next question? So you have measured the systolic blood pressure of an SRS of 25 company employees. A 95% confidence interval for the mean systolic blood pressure for the employees of this company is from 122 to 138. That's the interval. Which of the following statements is true? Read the 5 possibilities carefully. One of them is correct. The other ones have some of the right information, but not using the right verbiage or not in the right order. So read carefully. Alrighty. So let's consider what we've got going on here. So most of you guys have answered this question, and I can say 5 of you are correct. So let's look at the answer. All right, so the correct solution on that one was C. If the procedure were repeated many times, 95% of the resulting confidence intervals would contain the population mean systolic blood pressure. All right. We need to take cues from the context here. The confidence interval is for the mean. So anything talking about proportion, it's not going to be the correct answer because we're talking about means and not proportions. So you can rule those out. You then need to, this is the only one that fits one of the two contexts or one of the two concepts that we've talked about with interval and confidence level, right? If it says 95% chance, right? If it says like, hey, this is a 95% chance of this thing happening, that's incorrect, right? We have 95% of our intervals might contain this thing. We have 95% confidence. We don't have a 95% probability or a 95% chance. So those are also words in these contexts that don't belong. Right. Is there anything I can clarify on this one? Okay. All right, so that's the end of our practice problems. I know that we are just a bit over an hour here, so thank you guys for sticking around and participating. I'm going to say the practice problems for section 8.1 are available in Canvas, so if you want more practice, need more practice, please take a look at those problems so you can put in a little more time with this concept. The solutions will be ready soon. definitely by the end of the week. I'm working on them right now. And also take a look at the resources, the PowerPoint presentation from yesterday, right? The study guide that's now available in Canvas. Look at those different things. The videos that are available also in Canvas. If you have any questions, if you need any other help or support, please let me know. You can stick around and ask for help right now, or you can send me a message. Other than that, I hope you guys have a wonderful rest of your week and an excellent weekend, and I will see you next week. All right.